Problem number 6 on your page 26 on your class notes. We have a vector addition, 5 newtons at 50 degrees plus 4 newtons at 320 degrees. The scale was given, 1 newton is equal 1 centimeter. We are using tip to tail method for vector addition. Following the rules, we have to draw a grid. It's already done. The second one, we are going to locate 50 degrees on this grid. To do that, we are using a protractor. So place the protractor on the center of your grid and find your 50 degrees right here. Make a little mark. And now, using the same protractor, draw a very light line just to give you orientation where your 5 newtons is located. Then use your ruler in centimeter. So 5 centimeter. And this is your first vector. Our second one is located at 320 degrees. So we know should be around here. Use your protractor upside down. Line up your protractor with your grid. Now here, you need to think a little bit. Here is 270 degrees. To go to 320, you have to add 50 degrees. So let's count 50 degrees counterclockwise. So we have 10, 20, 30, 40, 50. So 50 degrees will be right here, even though the number does not match. Then, very light line, connect the center of the grid with the mark that you just did. Use the ruler to draw your 4 newtons using like the scale 4 centimeters. So right here, 4 centimeters. Second, we need to line up those vectors using tip to tail rule. To do that, what you need to do is close this box and move this vector up. Move the smaller, you can move any, but for the purpose of this practice, move the smallest one so we have the same results. This one here is canceled. So as you see, they are lined up tip to tail. That's why it's called tip to tail method. Next, we are going to connect the lonely tail with the lonely tip. This is our resultant. Now, we are going to place an arrow by the tip of this vector. Now we can label. So this one here is your 5 newtons. This is your 4 newtons. This is your resultant. And the angle between both tails, we are going to call X. To find the resultant, since it is a perfect right triangle, we are going to use the Pythagorean theorem. So R square is equal 5 square plus 4 square. So R is equal to square root of 5 square plus 4 square. Using a basic calculator, 5 square plus 4 square equal square root, 6.4 newtons. Now, using the same scale, you can verify if you got the right value. So right here is about 6.4. Good job. Now to find x, we need to use inverse of a tangent. Because this is a right triangle, so the opposite is 4, adjacent is 5. So our angle x is 4 divided by 5. Inverse of a tangent is 38.66 degrees if I round this part. This decimals, 38.66 degrees. Next, we need to find the location of R. So R is the distance counterclockwise from 0 to where the vector is located. So from here to here. So this is our direction or data. To find data, you have to look what you have. So right here we have the location of this 5 newtons, which is 50 degrees. So I can say that your data is your 50 degrees plus minus x will give you data. So data is equal 50 degrees from here to here. We have 50 degrees minus x. Data is 50 degrees minus 38.66 degrees. So data is 11.34 degrees. To find our final answer is, the resultant is, the magnitude is 6.4 newtons at 11.34 degrees. This is your final answer.